Hello everyone. I hope you all are fine. Welcome to my channel My Ganit by Tinker. Today we will be discussing about determinant, its properties, adjoints of matrix and inverse of matrix. So let's get started. First topic is determinant. Okay, so suppose we have a matrix A, okay, of order n. Then determinant of this matrix will be denoted by this mod sign of A or depth of A or delta. Let's understand determinant by an example. Suppose a matrix A having values 1, 2, 3, 3, 2, 1, 4, 2, 1. Okay, so determinant of this matrix A will be 1 into 2 minus 2 minus 3 into 2 minus 6 plus 4 into 2 minus 6. So determinant will be 0 and plus minus 4 and 3 is 12 and minus 4 4 is 16. So determinant will be minus 4. Okay, so determinant of this matrix A will be minus 4. And you should know that this value is unique. You should know that this value is unique. Okay. Now let's discuss why we are studying about determinant. Okay. With the help of determinant, we can identify whether or not a matrix has inverse, okay, or in other words I can say that whether an inverse exists or not we can check by determinant. Okay, suppose if determinant of any matrix is equals to 0, then there will be no inverse of that matrix, or we can say inverse does not exist for that matrix. No inverse. Matrix having determinant equals to 0 is called as singular matrix. Singular matrix, and matrix having determinant not equals to 0 is called as non-singular matrix. Now another use of determinant is we can find characteristic equations, and from that we can find eigenvalues of matrix. We can find eigenvalues. Now let's read about some of its properties. Okay, so let's study about properties. First property is determinant does not change on doing transpose of matrix. So I can write here as determinant of A will be equals to the determinant of A transpose. Okay, determinant does not change with transpose of matrix. Okay, next property is interchanging of rows or columns will change the sign of the determinant, which means suppose if we have a matrix A having first row, second row, third row, or first column, second column, third column. If we change second column with first column, then our determinant sign will also change. Okay, this can be represented by minus 1 raised to power m into determinant of A. Here m represents the alteration numbers. Okay, in this I have just interchanged one time, so here value of m will be 1. If I interchange again any other column, suppose I interchange column 1 with column 3, then m value will be 2 now, and determinant will be this one, determinant A. You can see here, whenever we will do alteration at even numbers of alteration, determinant will be same, and whenever we will do odd number of alterations, our determinant sign will change. Okay, next, third property we have, if row or column have identical elements. Let me show you with this one example. Suppose our matrix we have 1, 2, 3, 2, 4, 6 and 5, 7, 8. Here you can see that if we multiply column 1 with 2, we will get column 2. So these two columns are identical. Okay, so for this matrix the determinant will be 0. Okay, for any matrix having identical rows or columns, the determinant of that matrix will be 0. Okay, next property is property number 4, which says when we multiply any row or column by any scalar value, let's say k, determinant becomes multiple of that scalar value. Let's understand by example. Suppose k is a scalar value and we have a matrix determinant A, B, C, D, E, F, G, H, I. Okay, so if I multiply k with first row, suppose, so it will be Ka, Kb, Kc in this form, and when we will solve this, we will get k times of determinant of A. Okay, so you can understand the statement that whenever we multiply any row or column with any scalar value, we are going to get determinant multiple of that scalar value. Okay, suppose if I multiply k to k row 2, then our determinant will become k square of that A. Okay, next property is determinants can be written as or expressed as the sum of determinants. Suppose we have a matrix X 4 y plus 3 6. We can write this also as X 4 y 6 plus 0 4 3 6. Okay, you can understand here, if nothing is there, 0 is there. Okay, next property we have, if we add or subtract multiple of one column or row to another column or row of matrix, the determinant will not get affected. The determinant will not get affected. What this statement means? This statement means, suppose we have a matrix 1, 2, 1, 3, 2, 5, 2, 4, 6. And if I apply some operation on this matrix, let's say I change column 1 like C1 plus 2 times of C2. This kind of operations, when we do on matrix, our determinants will not get affected. Okay, determinant will remain same. Now I will tell you some practical examples where we use determinant to solve our problems. Okay. First example is, suppose you are given with 2 points x1 y1 and x2 y2 are the coordinates of these 2 points, and you have to find the straight line passing through these 2 points, which means you have to find the equation of the line, this line, which is y equals to mx plus c. Okay, here m represents the slope of this line. So with the help of determinant we can find this equation. Okay, how? Let's draw a matrix for this condition. In the first row we will write the variables x, y and 1. Okay, in the next second row we will write the coordinate 1, x1, y1 and 1. In the third row we will write the coordinate 2, x2, y2 and 1. Why I am writing 1 here? You can see here we have 1, 2, 3 rows here, so we should have 3 columns also. So I am just adding extra column C3 here. Don't worry, this 1 will not put any impact on the determinant of this matrix. Okay, so when we solve this determinant, we will get the equation of this line. Okay, y equals to y2 minus y1 upon x2 minus x1 into x plus y1 x2 plus x1 y2 upon x2 minus x1. Here it will be minus sign. So you can see here this equation represents the equation of the above line. Okay, here m is this part and c is this part. Okay, I hope you understand this. Next example is when we find cross product of 2 vectors. Suppose there are 2 vectors A and B. A vector having component A I cap, B j cap, C k cap. Okay, another vector B whose elements are A1 I cap, B1 j cap, C1 k cap. Now if we have to find the cross product A cross B, I can write in the determinant form it as I j k cap in the first row. In the second row, I will write the components of A vector, that is A, B, C, and then in the third row, I will write components of B vector, which is A1, B1 and C1. Now, after solving this, we can find cross product of these two vectors. Okay. Next example is, whenever we are given with any polynomial in 3D, whenever we are given with any polygons in 3D, we have been asked to find the equation of that polygon. We can do that with the help of determinant. Okay. Next, now we will study about the adjoint of matrix. Okay. What is adjoint? Adjoint is nothing but the transpose of matrix of cofactors. Suppose we have a matrix A, okay, of n order, and we have found its cofactors, which is represented as Cij elements inside this. So if we have to find the adjoint of matrix A, I can simply find the transpose of this matrix and we'll get the adjoint. Okay, so I can write here as Cij transpose. Okay, I hope you got this point. We have a theorem related to adjoint of matrix, and theorem says for any square matrix, okay, of order n, we have equation A of A adjoint equals to adjoint of A into A equals to determinant of A into In. Here In is the identity matrix of n order. Okay. Now we will study about inverse of a matrix. Okay. What is inverse and why we use inverse? Actually, inverse is used to solve system of equations. Okay, there is no division operator for matrices. That's why we have to solve by multiplying matrices with inverse. Okay, like I can't divide A matrix by B, so I just multiply A with B inverse. Okay. There are three methods to find inverse of any matrix. Okay. First one is, we know how to find adjoint, we know how to find determinant. Then now we have a formula which gives us relation between inverse, adjoint and determinant. We can find A inverse just by dividing adjoint of A by determinant of A. This will give us the inverse of A. Next method we have elementary transformations. In which we have two subparts. First, by row transformations, or second we have column transformations. We will discuss this in few minutes. And third method is when you are more privileged and you are free to use calculator or online tools, then third method is using online inverse calculator. Just put the values and calculate. You will get the value. Next, now let's discuss about the elementary transformations. What is elementary transformation? Whenever we apply certain operations on rows or columns, inside a matrix are called elementary transformation. Okay, and what are these operations? First operation we apply is interchanging of rows or columns. For example, Ri changes to Rj. Okay, we just interchange the position of row 1, elements of row 1 with the elements of row 2 or any other rows. Similarly with the columns. Second operation we have is multiplying elements of row or column by any scalar value. Let's say I am doing an operation on row 1. Then, and what operation is? I am just multiplying a k value to the row 1. So I will write this as like this. Third operation we have is of adding any scalar multiple of one row or column to another row or column. Okay, that is third operation. Let's say I am operating in row 1 as R1 plus 3 times of R2. So this operation is the third one of elementary transformations. By using all three operations, we will be able to find inverse of matrix. Okay, so let's understand method to find matrix inverse. The step 1 will be just write matrix in the form like this. A equals to IN A. Here IN represent the identity matrix of order n. Now we have to apply all the elementary transformations, all the elementary operations on A matrix to make it I, which is identity matrix, and we will apply same operations on this I matrix on our right hand side to make it as B matrix, okay, which will be our result A inverse. Okay, let's understand matrix inverse by an example. Okay, let's assume a matrix A whose elements are 1 3 4 1 3 4 2 1 4 2 1 4 1 2 3 1 2 3. Okay, now we have two ways to start the process. First, we can write this matrix as A equals to I N A in this form. We have just discussed about this. And another one is we can create an augmented matrix from this. Okay, and so what will be the benefit for this augmented matrix? The benefit is we don't have to write equal or opposite A sign, A symbol throughout the solution. Okay, so let's start. First, let's create an augmented matrix. Okay, now it will be 1 3 4 2 1 4 1 2 3 1 0 0 0 1 0 0 0 1. Now the process starts with A11 element, and we have to make this element 1, and as you can see it is already 1, so we can go to the next step, which is making elements of same column of our row 2 or row 3 0 with the help of row 1. So I am putting in operation R2 as R2 minus 2 times of R1, and in R3 as R3 minus R1. Now you can see the matrix will become 1 3 4 1 0 0. This will become 0 minus 5 and minus 4 minus 2 1 and 0. And next R3 will become 1 minus 1 0, 2 minus 3 minus 1, 3 minus 4 minus 1, 0 minus 1 minus 1, 0 and 1. Next, now we can go to the column 2. Next step is to make row 2 element A22 as 1. For that, I want this 1 in row 3 in the row 2. So let's put operation on R3 and we'll get R2 on its own. Okay, like R3 I'm doing minus of R3, and after that I'm doing R3 interchange to R2. Okay, now let's write this here. I have solved the matrix 1 3 4 1 0 0. Now R3, this will be 0, this will be 1 1 1 0 minus 1, and this will become 0 minus 5 minus 4 minus 1, so minus 2 and 1 and 0. Now next step is to make other elements of column 2 0. For that I am doing R1 as R1 minus 3 times of R2, and on R3 I am doing R3 plus 5 times of R2. Okay, now you can see here it will become 1 0, and 4 minus 3 it will be minus 1, oh sorry, 1 0 1 1, this will become 0 0, and minus 4 plus 5 plus 1. Okay, next we have in this side we'll do 1 minus 3 R2. Okay, 1 minus 3 minus 2, then 0 0 will get 0 only, then we will get 0 minus 3 it will be 3, next R2 will be same, 1 0 minus 1, and R3 will become 3, and 1 plus this become 1, and this one become minus 5. Now next step is to make R1 and R2 element of same column 3 0. So for that I am doing R1 as R1 minus R3, and again in R2 as R2 minus R3. Now we'll get 1 0 0 0 1 0 0 0 1, and along other side we'll get minus 5 minus 1 8. Okay, next minus 2 minus 1 4 and 3 1 and minus 5. Now you can see here we were initially you can see here we had initially this matrix, okay, and on right hand side we had identity matrix. Now after solving all these, now we have identity matrix on left hand side and our inverse matrix on right hand side. Yes, you heard it correctly. This part of the matrix is our inverse of matrix A. Okay, A inverse. Next, let's quickly check the properties or theorems of matrix inverse. Okay, properties and theorems. First one is every invertible matrix possesses a unique inverse. Okay, so if there is any matrix A, then there will be only one and only one matrix inverse. Next property is a square matrix is invertible if it is non-singular. Okay, determinant should not be equals to 0. Only then it will be invertible. Okay. Next, we have theorem called as cancellation laws. Okay. Cancellation laws, which has two parts. First, left cancellation. Second, right cancellation. In left cancellation, suppose we are given with AB equals to AC. Now you can see here the left matrix for both sides are equal, so we can cancel that, and after that we'll get B equals to C. This is called the left cancellation law. Next we have BA equals to CA. You can see here on the right hand side A is equal, so you can write B equals to C. This is called right cancellation law. Okay. Next we have reversal law. Reversal law we have already studied during the transpose class. What reversal law says, that for any square matrix A and B, there will be A, B product whole inverse will be given as B inverse A inverse. Okay. Next theorem we have related to transpose and inverse, which says inverse of a transpose will be equals to transpose of inverse. So you understood this? Next we have related to adjoint. It says adjoint of a transpose will be equals to transpose of adjoint. Next property is adjoint of A will be equals to determinant of A raised to power n minus 2 into A. Here n represents the order of the matrix. Okay. Next we have a theorem which says the product of two non-null matrix. Suppose we have one A matrix which is not null matrix and another B matrix which is also not a null matrix. Then it says product of these both if is equals to null matrix, then both of these matrix A and B will be singular matrix. Okay. What that means? That means determinant of A equals to 0 or determinant of B equals to 0. So I hope you understood this topic, and if you have any doubt related to today's class or any other doubt, feel free to comment in the comment box. Okay. In next class we will study about orthogonal matrix, rank of matrix, and properties or theorems related to rank. Okay, and we'll do some examples problems also. Okay. So that's all for today. Please like, share and subscribe. Thank you.